Hi everyone, it's Coach Fred, and today I'm going to be going over complex numbers. Now, this should in no way, none of my videos should in no way dissuade you from investigating these ideas and figuring out the patterns that exist and looking at the structure. This is just a review of what we've done in class, so I want you to always have this as a tool. So today, again, I'm talking about complex numbers, and as a guide or a definition for a complex number is a combination. It's a number that is a combination of a real number and an imaginary number. Now, remember, we've talked about the idea that real numbers we can plot and graph on a coordinate plane. Or a number line, and imaginary numbers have their own plane called the complex plane. So when we're looking at complex numbers, they're going to be in the form a plus bi. We call that standard form of a complex number. The a is the real part, and the bi is the imaginary part. And you'll often see in books and standardized tests and even like your homework, it'll say leave your answer in a plus bi form. Okay, so because that's how we're going to want to always write our imaginary numbers. Now, we're going to talk about why that is and how you graph that on a complex plane. But for now, we're just going to look at the operations: add, subtract, multiply, divide, complex numbers, and solve. Okay, so let's review the imaginary unit, the number I. Now, it is a number. It's imaginary. And so we've talked about the fact that I equals the square root of -1. So let's see if we can complete the pattern to the numbers. Let's go all the way through 8 if we can. So if we square I, we're going to get -1, right? Because that square is going to undo the square root. So I squared would equal -1. All right, now if we cubed I, we would get, well, we get I squared, which is -1, times the square root of -1, which is I. So that would give me -I. Okay. Now, if we raised it to the 4 power, that would give me the square root of -1 to the 4, which would really be I squared times I squared. So -1 times -1 would give me 1. Okay. And if we keep going with this, we're going to see that we're going to get I, -1, I, 1. And in class today, you guys made a conjecture about this pattern. And the conjecture was that the powers of I repeat every 4 powers. And so we kind of walked through that. That would mean that I to the 9th would be I to the 10th would be -1, I to the 11th would be -I, and I to the 12th would be 1. Okay. We also then looked at our calculators and the idea of dividing by 4 to actually find those values. So I thought it was really neat that what you came up with was that if you divided the power by 4, you'd get a remainder 1, and it would be equal to I. If you got a remainder 2, it would be equal to I squared. If you got a remainder 3, it would be equal to -I. And if you got a remainder 0, then it would be equal to 1. And what was even more interesting was then those of you that grabbed your calculators, you saw that if you divided the exponent by 4, you got 0.25, 0.5, 0.75, and then it went in evenly. All right, so let's use that to evaluate I. All right, so I to the 25, so we can take that idea that it repeats, divide it by 4. That's going to give me a remainder 1. So I to the 25 is going to just be I. I to the 39, I did it 39 divided by 4, which gave me a remainder 3. Doesn't really matter how many times it goes in. I'm just really looking at the remainder. So that would be -I. I to the 100, 100 divided by 4, we know goes in evenly, which that's going to give me the number 1. And then this one, you can see clearly is going to have a remainder 2, which would give me negative 1. Now, as a review on the calculator, this would have given me 0.25, 0.75. It would have gone in evenly, and this would have given me 0.5. So whichever way you did it, you can evaluate powers of I using the pattern of 4. All right, so that was a good start. So that was video number 1, and you're going to look ahead to how to multiply and divide with powers with I in the next video. Have a great day.